Hi, welcome to Nomis Academy. This time we will be dealing with inverse of SOHCAHTOA, trigonometry. So our topic remains trigonometry. Trigonometry. Yes. Trigonometry. I want to deal with inverse of sine, cosine, and tangent. Inverse of sine, cosine, and tangent. Now recall that sine theta is equals to opposite all over hypotenuse, and cos theta is equals to adjacent all over hypotenuse, and tan theta is equals to opposite all over adjacent. Let me bring it to your notice that cos theta all over tan theta is equals to sin theta. Cos theta all over tan theta is equals to cos theta. Now let me bring it to your notice that sin theta all over cos theta is equals to sin theta. So what I just said is that tan theta tan 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 theta is equals to sin theta all over cos theta. And how is that? So I'm going to prove it for you before we move on. So remember that sin theta is opposite all over what now? Hypotenuse. So divide by cos theta is adjacent all over hypotenuse. So by the time you solve this, this becomes opposite all over hypotenuse multiplied by hypotenuse all over adjacent. So hypotenuse cancel hypotenuse. I'm left with opposite. So the same tan theta is equals to opposite all over adjacent. So you can see it, opposite all over adjacent. So you can see that this is equals to this. So definitely the ratio of sin theta and cos theta is equals to tan theta. So put this at the back of your mind. It will help us. Now let us move into the inverse. The inverse of sine, cos, and tan theta. So let's get into the business. So if we're talking about the inverse now, so sine theta is equals to opposite all over hypotenuse. So the inverse, let's say 1 all over sine, that's the inverse, is equal to, definitely this numerator comes up and denominator comes down. So it becomes hypotenuse all over opposite. So the inverse here is known as cosec theta. So I'm telling you that cosec theta is equals to hypotenuse all over opposite. So that is that. The inverse of sin theta is cosec theta. So what about cos theta? Cos theta is equals to adjacent all over hypotenuse, right? Yes, that's correct. So the inverse 1 all over cos theta, it becomes the other way around, so that hypotenuse comes the numerator and the adjacent becomes the denominator, adjacent. So 1 all over cos theta is equals to hypotenuse all over adjacent, and this is just sec theta. sec theta. So I'm telling you that sec theta, which is an inverse of cos theta, is equal to hypotenuse all over adjacent. All over adjacent. So that is that. So the which is the last one, which is tan theta, tan theta, tan theta, tan theta. Tan theta is equals to opposite all over adjacent. So opposite all over adjacent. So what do we now say is the inverse of cos theta? Remember that the same tan theta is equals to sine theta all over cos theta. So if I now talk about inverse, that is 1 all over tan theta. 1 all over tan theta is now the inverse, so that cos theta comes up and then sine theta comes down. So if this becomes the case, sorry, don't mind my tan. So if this becomes the case, you will remember that cos theta is equal to cos theta is adjacent all over hypotenuse. So divide by, you know that sine theta is opposite all over hypotenuse. So this become adjacent hypotenuse multiplied by hypotenuse all over opposite, right? So hypotenuse delete hypotenuse, or let's say divides hypotenuse. So we are left with adjacent all over opposite, and this is the inverse of tan theta. We call it cot theta. We call theta, cot theta. So inverse of tan theta is equals to cot theta, which is equals to adjacent all over opposite, which is equals to adjacent opposite. So how do I get this memorized on my brain, so that anytime I will need them, I will not need to start looking for what to do again? Yes, inverse of sine theta, we said, is equal to cosec theta. And we say this cosec theta is hypotenuse all over what now? All over opposite. So let's take it to be cosec HO. So the inverse of cos theta we say is what now? We say is sec theta. And we say that sec theta hypotenuse adjacent. So if we take the abbreviation, we have SHA. Just like we took SOHCAHTOA, so we are taking the inverse of SOHCAHTOA. So 1 all over tan theta is equal to 1 all over tan theta is equal to cot theta, and we say cot theta is equal to adjacent all over opposite. So this can become CAO. So we have SOHCAHTOA. So please put all this in your memory. For sine theta, cos theta, we have SOHCAHTOA, and for the inverse of SOHCAHTOA, we have inverse SOHCAHTOA. So this tells relationship between an angle and a side or sides of the. Let's take some examples in SOHCAHTOA. I mean the inverse of SOHCAHTOA. So let's take example 1. So example 1 says that if sine theta is equals to 4 over 5, comma, find Roman figure 1 cosec theta, Roman figure 2 cot theta, Roman figure 3 sec theta. So let's get into the business. So solution. For we already know that sine theta, which is 4 over 5, is telling us that the hypotenuse is 5, and the opposite is what now? Is 4. So I believe that you can easily tell what the adjacent would be. Yes, the adjacent is 3 now. So now that we've gotten that the adjacent is equal to 3 centimeter, let's deal with cosec theta. So we know that Roman figure 1, cosec theta, which is our CHO. Remember it with CHO. CHO simply means that cosec theta is equals to hypotenuse all over opposite, and hypotenuse is just 5, and our opposite is 4, so that is 5 over 4. So Roman figure 2 says I should find cot theta. So cot theta, I know cot theta is the inverse of tan theta, abi? So cot theta, so that is cow. So I know that cot theta is equals to adjacent all over opposite, and the adjacent here is 3 and the opposite is 4. So it's as simple as that. And in Roman figure 3 we have sec theta. Sec theta is the inverse of cos theta. So and that is our sha. So cow. So this is our sha, and that sha simply means that sec theta is equal to hypotenuse all over adjacent, and the hypotenuse is what now? 5 all over the adjacent is 3. So this is our answers for the sign. So we just found the inverse of SOHCAHTOA. So we can use SOHCAHTOA anytime we need. We can use SOHCAHTOA anytime we need, and then use the Pythagoras theorem to solve further problems in trigonometry. I believe you understood everything that we did in this video. If you have not gotten some parts, pause the video, go back, watch again, drop a question in the comment section below, and then we attend to you. Watch it carefully and get this basic before we move to the deeper parts of trigonometry. Bye bye. See you in the next video.